to hit that button. Oh my god. Okay, this is a button on the YouTube website you're supposed to hit. That's probably why Nightbot wasn't working. Wait. Stop. Okay. Sorry you can hear me twice. Okay, well now I know. Does Nightbot work now? Come on, Nightbot. I'm sorry I'm taking so long to actually get into the math, but this is... You can't troubleshoot certain YouTube things off stream, unfortunately. Actually, there's a lot of YouTube things you just can't troubleshoot off stream for some reason. Okay, well, it's still not quite... It's still not here for some reason. It's not even in the channel. I don't know why. But let's just focus on the math. I'm not figuring out right now. So rotate GH. Oh wait, now Nightbot is working. Okay, just took a second. Okay, I feel a lot better about that now. Okay, rotate GHJ using center G until GH is lined up with ST. Till, oh wait, so they're working with the other triangle? Okay. Rotate GHJ using center G until GH is lined up with ST. Then reflect over a line halfway between GHJ and STU. That leaves a lot to the imagination, but I guess I don't see why it wouldn't work. Like how exactly you're defining halfway. I mean, it's probably the same no matter where you define it, but... Okay. Hey, Felix. You got top grade? Nice, Felix! You get your grade back instantly? I don't know how that stuff actually works. Either way, that's awesome. Do that here in Denmark? Okay. Well, congrats. So is that for a master's or for a PhD, I guess? Because I don't know if that's particular to one type of degree or not. Master's? Ooh, awesome. Is that like is that like the last thing you have to do? So you're like in the clear now? By the directed line segment GS? Okay. Missing one exam and then you're done? Wow, that's super exciting. Congratulations. Just don't mess up the one exam, I guess. That would suck. Okay, so I think maybe the point is, I think these are all things that would work, but you have to consider scenarios where they might not work. So maybe A wouldn't work because, like, what if GHJ was like on the bottom here or something? Hey, this is kind of a weird question. 2 months to the exam. Oh, okay, good. This is hurting my head. Why do you need to be this specific? I don't know what the point of this problem is. Translate GHJ by the directed line segment GS. Well, shouldn't you only reflect if necessary? If they're going to take this angle? Like, what if this is arbitrary and what if this is set? Or maybe everything is set and there's something that I'm missing here. Here's the line segment GT. Using T as the center. So this entire triangle would shift up until G meets T. Rotate GHT using T as the center by angle HTS. HTS. Oh my god. Yeah, okay, I'm glad I'm not the only one. Hmm. Because I can't. It's kind of hard to poke a hole in any. Like, it depends on, like, how arbitrary you're being, I guess. GHJ by the directed line segment GS. Translate G prime H prime J prime by the directed line segment HT. Okay, so making G meet S and H meet T. Translate GHJ by the directed line segment JT. Yeah, the reflection is mirroring it. I think D is right out. It needs to involve a reflection. So I've at least gotten that far in this problem. Now, what's the difference between A, B, and C? Like, A sounds kind of complicated. Like, you could interpret a line halfway between GH, J, and STU many different ways, I guess. You think A is right? Shit, I don't need to troubleshoot Nightbot. I can take that node out. Translate GHJ by the directed line segment GS. Yeah, I think I get that. I'm just assuming if there's a lot of ambiguity in how you draw that line. Hey, hardlocked. I don't know. I think A, B, and C would all work, but we have to find a hole, some way that you can misinterpret it. Other math people smarter than me. You say hello, Don, and math people smarter than me, because I feel like I'm like, the more I do the stream, the worse at math I feel. Oh shoot! Charge my phone so it doesn't die on me. midstream like it usually does. Segment GS. Rotate GHJ using S as the center. Maybe the problem with B is reflecting it when it's already in place, and that reflection is going to make it move? Depends on how you define a reflection, I guess, but I think B sounds wrong, yeah. C, you bring G up to T, or you bring the entire thing up to T without... You bring the entire triangle up until G meets T, and then you kind of swing the triangle down. But then you have the same, they're right on top of each other, and then you reflect, which maybe that's the issue. Open to interpretation, I'll say. Involve reflection. This one, I'm just going to save the answer, I think, because this is such a weird one. I'm not even confident if I'm right. Both involve a reflection while the while triangle GHJ is already in place, which could maybe mess up the positioning of the triangle, which would make me think A is correct, since it accounts for the movement with a reflection. You draw it. No, I think I understand what A is doing. It's just, I don't necessarily see what's bad about B and C. It just feels a little vague, I guess. Oh wait, chemistry? Never mind. The rotation you do doesn't merge them? Oh. Maybe I was assuming that they would merge them. Okay. Oh, they're defining all these functions implicitly. I guess y equals 4 is explicit, but... Let's do this. I bet we're going to want to integrate in terms of y. If I were a betting man. My hotkey works again, thank you. Okay, so we have 2y equals 3 root x. We have y equals 3 or 4? 4. And we have the standard form of a line u. 2y plus 3x equals 6. Actually, in this case, the standard form is actually kind of helpful. So I think it's going to be helpful to label points, like specific points here. Okay, so y equals root x is a sideways parabola opening up to the right. But we have the 3/2 in front. Actually, so the issue is, ooh, there's kind of, I need to see what this region looks like. Technically, this is only the upper half of a parabola. If you write y squared equals x, that's a parabola opening to the right. But if you already write y equals root x, that's only the upper half. Okay. So let's just plug in values for x. We're only going to take the upper half of this parabola. So 0, 0. If you plug in 1, you get 3 over 2, which is 1.5. If you plug in the next perfect square, which is 4, you get y equals 3. So it's a parabola like that. And I guess y equals 4 is just that. The parabola will eventually go across y equals 4. And then we also have 2y plus 3x equals 6. So plug in, just find the intercept for each one. The y-intercept when x equals 0 is 3. Then when y equals 0, x is 2. So the region that's enclosed is this. It's also a little bit in the negative area. So after seeing this, you're better off integrating in terms of x. I want to say. Because you're going to need to do one integral from y equals 4 down to the line, and then a second integral from y equals 4 down to the parabola. And doing that in terms of y is kind of hard. Well, you could do it in terms of y. Actually, it wouldn't be that harder. X is a little bit easier for me to interpret, though, and be sure that I'm right. Isn't it just to subtract integrals? If you were to do it in terms of y? I don't know how it exactly would work with, I guess the y is always positive, so we don't have to worry about that. If you did it with y, you do the parabola minus the line, which is also completely fine. Just in general? Oh. Oh yeah. Because you're either subtracting y equals 4 minus the line in y equals 4 minus the parabola, or you're doing the parabola minus the line. Oh, we could actually set up the integral, but I don't think I need to in order to answer this person's question. Two y equals 3 square root x is the upper half of a parabola. I guess I'll say a sideways parabola. Y equals 4 is a horizontal line. 2y plus 3x equals 6 is a line. Both x and y seem completely fine to me to integrate in. The trick is that with x, you need two separate integrals, and y is just one integral. Despite the above, Personally, I'd integrate in X because I'm a bit more confident I'd get it right the first time. Yeah, you can definitely do that. Of X, you'd have to do one integral with the horizontal line minus the, at least I'll say slanted line. The slanted line, plus another integral of the horizontal line minus the parabola. To integrate in terms of y, just do the parabola minus the slanted line. So let's get that, that's always a start for them. You know, I'm kind of curious just to try it both ways and make the answers match, because they should definitely match. So let's start off with doing it in terms of x. And so y equals 4 in the slanted line. When y equals 4, the slanted line is 6 minus 8 is negative 2. Divided by 3 is negative 2/3. So when x is negative 2/3 is when the horizontal line and the slanted line intersect. So from negative 2/3, the integral goes up to the intersection between the parabola and the line. And what is that point? When x equals... Oh, that's kind of annoying to figure out. For either way, you have to... Or whether you're doing x or y, you need to figure out this point. It is a little bit annoying. So let's just do that quickly. Let's solve that for... Solve it for x and plug it into the square root up there. X is equal to 2 minus 2/3 y. Rearranging the equation for the line in terms of x. Yep. Now plug it into the parabola. Divide by 3 and square each side. Oh my god. We can multiply everything through by 9. Divide everything by 2. Slightly easier. It multiplies to 18, adds to 3, that's negative 6, that's positive 6 and negative 3. So we need a plus 3 here and then a minus 3 here, potentially? 2y squared, 6y minus 3y minus 9. Oh, I got it right in the first try. Y equals 2/3 and negative 3. The negative 3 we don't care about, because that's like somewhere down there, where if the parabola had 2 sides. But we care about the 2/3 that's up there. But we need that in terms of x, so we can plug the 2/3 into either initial equation and figure out what the x value is. That's why I'm saying it's kind of a pain. Just plug it into the line, a bit easier to work with that. 4/3 plus 3x equals 6. I'm going to multiply everything by 3. Because I don't want to deal with fractions. What an annoying intersection. 14/9? Wait, when x equals 14 over 9, that's not a perfect square. What's the deal? Oh, because it's 3 over 2. I flipped the fraction. Okay. Some plug 3 over 2 in for y over there. You get 3 plus 3x equals 6. X equals 1? That's a perfect square, last I checked. And you get 3 over 2 back out if you plug x equals 1 into the parabola. Okay, that makes sense. So that's what we need to figure out the other bound. So we're going to integrate from negative 2/3 to 1. Okay. Now 4 minus the line. In terms of... Wait. It's y equals 4. Integrating y in terms of y is... Wait, no. And now that I actually do it, integrating in terms of y is just easier. Because it's... You'd have to get... I mean, it's not that hard. It's not that much harder to do it in terms of x, but you have to manually get the area of the rectangle under y equals 4 and subtract out. Well, no. Actually, no, this integral still works, right? If you integrate 4 between two bounds, you still get the area of the rectangle, don't you? This is a very basic question. I should know it offhand. I apparently don't. Okay, that is the area of the rectangle. Okay. And we're subtracting out the area under the line, so we get the area above it. Okay, good, good, good. Never mind. Still on track. So we also need the line in terms of y now, or not for y in terms of x. Yeah, you're getting all the areas separately, it sounds like? Well, you wouldn't want to go all the way over to the slate line being equal to 0. I don't think. Because you don't want to double count areas. Well, no, I mean, maybe you're not doing that. Yeah, no, your way is probably okay. It's going to be y equals 3 minus 3 over 2x. 3 minus 3 over 2, oops, x is our first integral. And then we're going to go from 1, and then where the parabola and the horizontal line meet. So that's 8 equals 3 root x, 8 over 3, and then you square 8 over 3 is 64 over 9. Okay, weird number. 4 minus the parabola is 3 over 2 root x. $925 over 108, kind of a mean number. And just to make sure, let's do this integral in terms of y, just for fun. Sorry, I'm getting paranoid about my YouTube stream too. I want to make sure that it's doing okay. I'm going to open it up again. Make sure the... Actually, yeah, I forgot to check the video. It looks better than it did the other day, which is good. It should look better because I messed with my bitrate. Okay. So yeah, doing the integral in terms of y. We're going to go from the parabola which is 4 over 9 y squared, down to the line, the slanted line, which is 2 minus 2/3 y, that I found before. The upper bound for y is 4 because of that the horizontal line. The lower bound is where the intersection happens in terms of y, which is 3 over 2. And hopefully this gets me the right answer, or the same answer. 925 over 108? Hell yeah, look at that, beautiful. So, honestly, doing it in y, easy. I mean, I got held up on a part or two of it, but I'll call it easy. You know, talk some smack. Just want to add on that I think y is just easier. It's less work, especially if you're doing it by hand and not using Wolfram Alpha like I am. Oh! Wait. They're saying that if you flip the fraction into the same log identity in reverse, you would get the same thing back, but that can't be right. No, I think you would get log base b of a if you flip the fraction. Let me look at the actual log identities, because I feel like I'm getting a little lost in the paragraph. So I guess let's get the change of base identity. This one. And so they're asking, what if you flipped the result of this and did log base d of b over log base d of x? In which case, you would get log base x of b and have the same thing back. So I think that's all. Let's actually make sure that their premise is right. I didn't actually check that. Log base a of b, what's inside the log goes on top? Okay, yeah, they did do that right. Log base a of b equals log base x of b over log base x of a. If I'm understanding you right, you're asking about what log base x of a over log base x of b is. You wouldn't, it would actually be log base b of a, not log base b, not log base a of b, as you said. Whatever is on top of the fraction becomes the inside of the log, and whatever is on the bottom becomes the base of the log. So I think the person think that, or they found something that looks like a contradiction, but I think they just applied the identity incorrectly here. Two comments, just make sure that there's an answer. Oh, there's an answer. Asking about two population here. Two population t-test. Two sample t-test, not two population. I need to remember the rules here, because I think you can, they either both need to be greater than 30, or you calculate like the pooled thing and see if that's greater than a certain amount. I don't think I like this website's explanation. Paired, no. Do not sell my information. Well, you're not really addressing the question here, website. This is a two sample. No, it's not just different. They just need to be above a certain threshold. I just don't know whether it's one or both, or how exactly that part works. So I know the rule by heart for one sample. Just for two sample, I don't. The student's t-test. The sample size is large, more than 30. No, but there's two populations. Two samples. You can't just say when the sample size is big. Which sample size, or which sample do you mean? Everyone, okay. I remember being taught like an explicit rule when I was taking stats. And why are all these websites avoiding the issue? Hey, day by day, what is the Hilbert transform? I'm not a good person to answer that question. I'm sorry. I haven't gotten that far in math. It's been just in a normal stats class where I never heard of Welch's t-test, but it's just a normal stats class. I'm like very sure they're talking about the students' t-distribution. They probably can't use that test. Even though it probably exists, if they haven't been taught it, they can't just use it. Ugh. Let's go back to looking at two-population t-tests. Working on your digital signal processing exam, that's why you asked. Oh, shoot. Volch's taste? It sounds very sugar-filled, Jed. Yeah, I'm sorry. I'm not familiar with the Hilbert transform. I wish I could help you, but I'm trying to get someone who might be familiar. I don't know if anyone who specifically dealt with the Hilbert transform, though, unfortunately. There are other math streamers over on Twitch in general. I don't know if any of them in particular would be able to help you out, though. Oh, shoot. That command gets cut off. Okay, I'm going to have to make that shorter. At least everyone's name is in the list, but unfortunately Simplex's link got cut off. I'll deal with it later, though. Oh, if the variance isn't approximately the same, you use Welch's. Oh, is Welch's just the more complicated formula? Also, I don't know by this name, but I think if the variances aren't equal, you have to use a more complicated formula, and the name of that might be Welch's t-test. Yeah, like that's for students. Oh, okay. So I do know. So no, they specifically said the variances are equal. The only thing that's ever here is the sample size. I don't imagine Zach would be. You could try though. I don't remember hearing him dealing with anything related to digital signal processing. But maybe. I mean, I don't know everything that he's done. Was this just one that? Yeah, it's the same one I was just looking at. Two sample sizes must be less than 30. Shoot. Okay, so that means that they would. Since that means if one of them is more than 30, you can do a z-test according to this website. Because that's really, that 30 mark is really a rule of thumb. It doesn't, you could do either. Hmm. where you could probably validly make either call. Most websites I found statistics tableaus and they don't go over values greater than t equals 30. So yeah, I know for one sample you don't go past n equals 30 for a t-test normally because it just becomes a normal distribution basically at that point. But when you have a 2 sample, I don't remember the rule if just one of them has to be greater or if they both do, or I'm just gonna kind of, I think it's one to really ask their teacher more than anything else. If either is greater than 30, you can use a z-test. I mean, I feel like different sample sizes occur all the time in research if you're comparing two separate studies. There's nothing special. The entire thing is more a rule of thumb. Than anything else. There's nothing more special about 30 than, say, 29, 31, etc. Your favorite area of math and why? I see my favorite area of math is modeling with differential equations. Unfortunately, I've forgotten more of it than I would like, but I got interested in it because I was a research assistant for a professor, and that's what they were working on, and I got very kind of interested in it. But yeah, I guess that's kind of I guess that's why I like it. But I graduated like 5 years ago or so, so I've forgotten a lot of what I've learned, unfortunately. No, Welch's t-test is when the variances aren't equal, not the sample sizes. So, the type of modeling we're doing, it was basically working with the SIR model, which is a system of ordinary differential equations, if I remember right. And we're applying this to viral social media trends, which of course is why they're called viral, because they follow kind of the spread of a disease. So we were taking a literal model for a disease and trying to apply it to a viral social media trend. And we were using MATLAB to kind of like do things and try and find specific solutions. You always found topology fascinating. Topology seems very difficult. I have not taken a class in it. I just have a bachelor's. It seems very weird. And I only vaguely know what it's slightly about. No, the sample size doesn't matter, Felix. Because you always end up combining them anyway in either type of test, whether it's students or Welch's. Like the formula have n1, n2 built into them. And out of those people that I linked, I remember e to the 2i pi or Zach mentioned just recently taking a topology class as well. If you're interested in like trying to like discuss it more, but he's over on Twitch, of course, and not on YouTube. But yeah, I don't know. There's things that I'd love to be able to discuss with people who come in like chat, but I just like I don't have enough foundation. Are you currently doing anything with topology day by day, or is it just something that you're interested in? Oh God, sampling and distribution. Let's see if I can remember this. There's a lot of stats. I'd rather do calculus, but people need help with stats today, I guess. Let me get put my mug away in the sink. Give me like 1 second. Okay. So I think for this, really the main difference is you divide your standard deviation by the root of your sample size or something like that. Let's see if I can remind myself of the rules here. Oh, hey, okay, I called it. And then now you keep your old mean. This is your new standard deviation, and then it's like a normal stats problem. And for proportions, it's going to be the same process. Just, oh, they don't actually show it with proportions. I was hoping to actually link them to that. Wait. Isn't that the normal formula for sigma with proportions? Wait, normal distribution proportions. How do you calculate sigma normally? Because I thought it's the same exact formula, PQ over N. You want to take topology, but you took theoretical maths during COVID, which is basically self-study. Oh. Maths for masters in engineering. Interesting. Yeah, I don't imagine you're going to be using topology for engineering. Unfortunately. You study robotics and automation in Trondheim. Wow. That's super cool, too. Wait, this is the exact same page? It is. In Prague on exchange currently, though. Wow, dude, that sounds amazing. Sampling distribution and sample proportion. All right, well, this is saying the same thing, I guess. What's the... Oh, wait, maybe it's root NPQ rather than dividing. A better thing for me to Google will be like one proportion z-test. That's why I'm not getting the Google results that I want. And when you have one proportion z-test, how do you get sigma here? Same exact thing. So it doesn't actually change? That's so weird. That's what I was getting confused on. Like, why is it the exact same? I guess for proportions, that's just how it works out, though. So what's wrong with their work here? I think their work is right. What, did they write anything? They're so lost. Normal, sigma sub p hat. Is that a negative sign in front of the 0.5? I think it's just a smudge, it's not a negative sign. Oh, well, okay, I think it's a little bit, I'm making it sound a little bit too simple and this person is lost. So let me not glaze over this much. From here, first you need to, well, if you're using a table, calculate the z-scores for the start and end points. Is 0.49 minus 0.5 over sigma sub p hat. Whatever sigma sub p hat comes out to be. And the end point is 0.51 minus 0.5 over sigma sub p hat. if you're using a calculator, you just enter the start point as 0.49, the end as 0.51, and give it p equals 0.5 and sigma equals whatever you get for sigma sub p hat. Okay, hopefully that helps the person, because hopefully they're on the right track, so I'm not sure exactly why they felt it was wrong. I do have a DM here, let's go see what's up with that. They are still A and B, but them being in different positions makes all the difference. Log base A of B does not equal log base B of A. What is this person saying? Is this person, I think this person seems to be saying the same thing as me in a different way. Correctly. Yes, A and B are still the same, but log base A of B is not the same as log base B of A. You can try it some different values of A and B, and you'll get different things. For example, log base 2 of 8 equals 3, but log base 8 of 2 is going to be, I assume, 1/3, right? Well, that's not... yeah, 0.33. The two are related though, because the answers are the reciprocals of each other. As /u/ this person did out. Okay. Specs looking for new questions. Did I already scroll past these once? Yeah, I did. That's where I ended, so let's keep scrolling past here. Does this have an answer? Yeah, it does. Okay, let's go over. Oh, I already have another reply. Oh, why doesn't the reply show up? Oh, the auto mod might have held it up. Oh, this person literally recorded a video. I'm kind of curious to watch it. I'm not going to do it right now, but it's kind of neat. They just made a video to answer someone's question. Is 0 to the I a meaningful expression? I have no clue. It means something, I'm sure. Whoa, I'm not following what this person is saying. I have no clue what this person is asking, I'm going to be honest. Hey, chessmate, how are you? Suits up with this person. So they said they thought it was 3. The correct answer is 2. See what the question is. Okay. When as xy approaches 0, if x squared y over x to the 4th plus y squared. All lines passing through 0, 0. I love your work. Oh, well, thank you very much, chessmate. I appreciate the kind words. Just want to say this is correct. So you'll be looking along all lines such that y equals kx. I think it's normally the technique that you do, where k is some real number. One takes the limits along all lines, but the limits might not exist. How about they do? Now it's been a while since I've done a multivariable limit with this technique. It's been a while since I've done a multivariable limit in general. How do you actually examine the y equals kx stuff? Multivariable limit along all lines passing through 0, 0. I just want to see like how you interpret. It's almost the exact same question as what we were looking at. Well, wouldn't it just y equals mx, yeah. Oh, they cancel some of the x's. Okay. Oh, this is an interesting explanation. Imagine a weirdly shaped cliff in the middle of the ocean. The blue is the ocean. Okay, that was my first question, which is what's what here? That's sea level. The green is a very long, very thin cliff or island or whatever. It's at the height of, say, 100 meters. It is in the shape of a parabola. I don't. Oh. I think I kind of get what this explanation is saying, but it doesn't make complete sense to me, at least. Because wouldn't you not be at the origin if the cliff is 100 meters? You'd be 100 meters above the origin? Hmm. Actually, wait. Shouldn't x squared over m squared plus x squared tend to 1? Because the degree on top and bottom are equal? I need to look at an example here. Like, we just have this one. Oh, it does go to 0. Why? Oh, because the coefficient rules for out to infinity. Duh. When x is very small, the bottom is greater than the top. I guess. Or if you have x approaches 0 here, I guess I would do L'Hopital's is the real answer. And you'll get 2 over... Wait. No, you can't use L'Hopital's. How do you do the limit as x approaches 0 of this? Am I... Oh, you do x squared plus 1 minus 1 on top. And you'll get 1 plus... Or 1 minus 1 over 1 plus x squared. Which comes out to be 1 minus 1 is 0. Okay. So I still need to wrap my head around what's actually happening here. So let me actually, well, did they show? Okay, so let's look at their work for what they did with y equals x squared m. You should be doing xm or mx, I would think. That might be their issue right there. So when they plug in x squared m anyway, let's just follow along their work and see what happens. They get x to the fourth m over x to the fourth plus x to the fourth m squared. The x to the fourths all cancel, you end up with m plus 1 over m squared. That clearly depends on your choice of m. So you can get many different limits along different lines. But x squared m is not a line. It gives some convenient cancellations, but it's not a line. think what it is, check along all parabolas with vertex 0, 0. Which probably isn't a bad technique to potentially find why limit can't exist as well. So if we do it the way the question intends, x, y approaches 0, 0, x squared y over x to the fourth plus y to the fourth, x fourth y squared. And we want to look at the limit. We're not going to say equals because it's not necessarily equals, but x comma mx, because y equals mx, approaches 0, 0 still. The points don't need to change. X squared mx over x to the fourth plus mx squared. Which is 0, 0. Mx cubed over x to the fourth plus m squared x squared. We can cancel out an x squared. I'm not going to keep writing the entire limit thing because it's really annoying. But you end up with mx over x squared plus m squared. And so I think from here, your choice of m does affect things. Actually, this is going to be our last line. Actually, no. The degree on the bottom is greater than the degree on top. So I think you always go to 0 regardless of your choice of m. You might go to 0 from a different direction. That part I'm a little bit fuzzy on. But you still get 0. Either way, the flaw in their work is definitely doing x squared rather than x. Finding that the limit is different along a different direction, parabolas, does help confirm to being correct though. Okay. Let's see what our DM is. They understand it now. Okay, good. Okay. Let's go back. I think I was on Ask Math. Bo Burnham has a song called New Math. I'm kind of curious to see what they're asking about. Oh, that's why you did it. Hey, Zach. Thank you so much. Wow, you're only just now? I would go for an hour. Wow, you had a marathon of a question answering session after just doing the class too. Quite the combinatorics prompt. Oh, interesting. Playing Trominos? Oh, like dominoes with 3 things? That's interesting. I don't want to look at this question, actually. Next week, Tetris? That's like a for fun question. Well, I guess Bo Burnham, the comedian, made a song about math, but I don't get it, so. So yeah, I just did a multivariable limit. Tromtris? Oh, geez. Mixed algebra. I don't, like, maybe involving 2 or more variables? I wish I provided an example. Oh, wait, okay. Would something come up if I Googled it? I don't think that's it. Oh well. If D means 2 and TR means 3, does that mean Dawn is the prequel to Tron? Don't even get me started on Quan. ln x over ln a is equal to solve a Rubik's Cube? Oh, all right. We're doing it. All right, we got our scramble up there. U2, R2, F2, L2. I think that one's back prime. Doesn't really matter because it's all a scramble. Oh my god. Jed. I'll deal with you later, Jed. All right, inspection. Okay. Okay. 26 seconds could be worse. Oh wait, such a Jed's redeemed by accident. Well now I really have to do it. Oh wait, you just did another one? So he's not showing up in my... Oh wait, no, wait, then where... I'm missing a redemption, apparently. Said you have channel, that's true. I have no idea what redeems I did or didn't accept, but either way, I'm gonna do the Rubik's Cube first because it's a lot quicker than what Jed wants me to draw. Wait, no, I think it's like that. Okay. Inspection. Oh no. I messed up. Ah. Oh my god, this is horrible. Horrible. Literally the worst. Ugh. Okay. All possible traumanos that fit in a 3x6 grid? What does a traumano look like? Oh my god, dude. Jed, you've seen me play Talos Principle. All possible free traumanos. I got it. Okay, I know exactly how I can draw this. Oh wait, I'll keep the headphones on. Doesn't matter. Okay, I'm gonna draw in red the color of anger. We have a 3x6 grid. One, two, three, four, five, six. So we can have, no. This is actually done because these are all the traumanos here. They're just overlapping. Okay? All the combinations are drawn onto that same grid. So I know it just looks like squares, but like, you know, there's a traumano there, a traumano there. There's a traumano there, and also there, and there, you know? They're just all overlapping. Last hour? It'll take me, yeah, it'll probably take me more than all stream. I have to do some extra streams. Could have requested a tessellation of your whiteboard? What? I don't know what a tessellation is. Tessellation. Oh, oh, it's a good word for code. Oh, where is that file? I mean, that might be a little bit too vague, but I'll put it in the list, and I can think about it more. All right, I added it into the list. Okay. I think I'm caught up on all the redeems. Okay. So they're trying to prove this identity. So they're working, I guess, with the left-hand side. I never actually tried to prove this. You're probably even more general and say log base b rather than using ln, but this works too. B, or so they say e to the ln x to the 1 over ln a. That seems valid. Well, you don't end up with x on both sides to prove an identity. Oh. I don't know how you would prove this, to be honest. Yeah, how do you go... I think they've already messed up by working on both sides of the equation here, but... And, like, how would you prove this? And where does this extra... Oh, they raise each side to the power of ln(a). So log base a of x implies that some other number y equals log base b of x, which also implies b to the y equals x. Oh! And then a to the z. So they... Wait. Oh, okay, yeah. So z equals log base a of b to the y using this substitution. And then you use the exponent rule to bring the y down. And we know that y is equal to log base b of x. Wait, hence the result? Where... Oh, you do the switching thing. They skipped the last step or two. So if you switch the base and the input, you can say that log base a of b is equal to 1 over log base b of a. Well, wait. No, now I'm just confused. What did they prove? So let's say you said z. Z isn't anything that we like. I guess z is log base a of x. Oh, you do. Okay. You remember that z is equal to log base a of x, and then from this stage you divide both sides by log base a of b? Okay. You're assuming the thing you want to prove is already true. Trying to prove an identity, you normally just work on one side of the equation. Or else you've made a logic error. working on both sides of the equation implies that the equation is already true. That's what we're trying to prove. I wonder if we can make their approach work. Technique of starting with one side of the identity and ending with the other side. It proofwiki.org, kind of an interesting site. Y equals ln x and z equals ln a. Exponential forms. With the desired identity. So proof one here. That link isn't going to work, is it? Because there's underscores. Oh, maybe it will work. Oh, it does work. Okay, good. This is Beard Bop on Twitch. Hell yeah. Beard Bop. That sounds like a good like emote name. I might be able to make some kind of emote like that. I don't know. I gotta think about it. Not a whole ton more questions to answer, unfortunately. Might do real analysis, or we might go over to the math Discord. I don't know what I'm more in the mood for. Man, today's just a stats kind of day, apparently. Let's look at this one, though. I don't know if I'll be able to do it. Ooh. I definitely don't know if I'll be able to do this. Why do you pull g of yz times hz out of the integral? Why do you need the integral in the first place? Ooh. Yeah, I don't remember this well enough, I don't think. I don't remember my calculus space stats well enough to do that question. I think I'm gonna switch over to real analysis because there was kind of a question that we had during that class that I want to revisit. So during the real analysis class, we spent like a huge portion of it on this one question that turned out to be a lot harder than it seems. What kinds of monotone sequences could converge? So monotone sequence either always increases, or it's always greater than or equal to its previous term. In a monotone decreasing series, it's always less than or equal to its previous term. And we said that it has to be bounded in order for monotone sequence to converge. Because it's monotone, it can't oscillate. So bounded is enough for us to go off of. So I need to remember exactly how we were constructing the argument here, because I don't think we really put a bow on the argument and put it together cleanly, and that's why I want to revisit it. I think I got the idea across and got it in my head, but it doesn't fully sunk in. So I'm just going to consider monotone increasing, because it seems like you need to prove these increasing and decreasing separately. A sub n bounded by k. So we'll be using for bounds. So this is something that it took a portion of time. We were kind of debating if something is monotonically increasing and bounded must have a supremum. For the sake of at least today, we were assuming that it does. I don't know if it's something we're going to dig more into for why, but actually, I mean, okay. Since a sub n is bounded, well, it's not how you spell bounded, is it? Let L equal supremum, because we want the minimum upper bound. And I'm calling it L because supremum is going to be our limit. Since L is the supremum, then actually I feel like I don't need to say that. Now we're going to bring epsilon into here. Let epsilon be greater than 0. If L is equal to supremum of a sub n, which it is, then L minus epsilon is less than a sub n. Because if just by the nature of the supremum, we can get very close to it. So if we're just a little bit below that supremum, we should be able to get that little bit close to it for some n. for some for some n is fine. We don't need to say anything more, I think, at this stage. Well, I mean, we could. I think there's a little aside that I think Mina was talking about whether we should say it's everything after a big n point, which I guess it doesn't hurt. I don't see why it would. We could say instead of for some n, we could say for all. For all small n greater than big N belongs to natural numbers. And then if we rearrange this inequality, well, yeah, let's rearrange the inequality right now in this moment. So this inequality implies, this is where I was getting a little bit tripped up and where I want to clarify that minus, be careful with the sign here. Let me do this in steps. Let me not skip straight to the end result, because I'm going to mess up the the sign of the inequality here. There, yeah, that's proper. Also, L plus epsilon is certainly greater than A sub n. That's just for all n. We don't even need like a cutoff point, because L is our supremum. So this means A sub n minus L is less than epsilon. As well. And now this thing with the signs is what I was trying to figure out during the class that I couldn't really quite get past, but the discussion kind of moved on and it wasn't the most important issue. It's going to be something involving absolute values. Is it as simple as if these two things are both true, then the absolute value is less than epsilon? Because in both cases of the sign, it's always less than epsilon. I think it's maybe as simple as that. Yeah, it works if I work backwards. I do want to compare it with what we wrote in class. So let me bring up that big image. Give me 1 minute. I don't bring up the work that we were doing in class. Oh yeah, I scaled this up, didn't I? So the work we were doing, oh my gosh. And our actual proof that we're starting to discuss a lot of things rather than actually writing them down, which is my bad as scribe. We didn't actually really write this down, did we? I feel pretty comfortable with what I have written, though, I think, in terms of it being true. I don't think I've done anything that's that crazy. Okay, for some reason, I thought we had written more, but I guess not. Either way, I think I've shown it for a monotone increasing sequence, so let's try and kind of do the same argument for a monotone decreasing sequence now. Um, oh, I wrote an epsilon there instead of an E. Jeez. So you know you're doing too much real analysis. Okay, so, oh shoot. Get rid of the cam. So same thing here, instead of increasing, we know of decreasing. So A sub n is bounded, let L equals infimum A sub n. Let epsilon be greater than 0. If L is equal to inf A sub n, then, so now here's where things get a little bit different. Because we have a sequence that's bounded from below here, basically. So L, I think, plus epsilon. No, L, what is L minus epsilon? Let's draw a little picture here. Just consider everything as positive. This is the line L. So L plus epsilon is slightly above, and our sequence could get inside of that kind of band. And L minus epsilon is below. Do we need to worry about negative values for L? Or will the same math apply? For negative L, you have a negative number. No, the sign is fine. Because plus still goes above, minus still goes below. We're good. So I said L plus epsilon is less than a sub n for all n greater than n belongs to natural numbers. That's not good though. Wait. This gives me epsilon is less than. No, I flipped the sign. I flipped the sign. There we go. Or rather, I kept the same sign and I didn't want to keep the same sign. This is actually true now, and it'll give us what we want. So epsilon is greater than a sub n minus L, but not absolute value. Necessarily. So we still need the other part of this, I think. It's less. This should be less than. These have the opposite signs, those have the opposite signs. Okay, good. So yeah, the negative version of this is also less than epsilon. I think I did it. Okay, I'm going to post this into Zach's Discord. I do need to get a screenshot of my board, so let me open up my own stream quick. Well, actually, wait, since I have the YouTube stream open. Oh, wait, it's... let me just turn the quality up. It's fine. Oh, I'm forced in 360 when I'm looking at it through the preview. Let me still open the YouTube stream because I want to check the quality of it anyway, as long as I'm here. Wait, the quality looks so much better than it did on Tuesday. Still not perfect, but at least improving. It's monotonically increasing. Okay. Got my screenshot. Let me go over to Zach's Discord quick and put this in the discussion. Prompt 5-8. Oh no, 5-9. I may as well just show it so you guys can see what I'm doing. end result for a monotonically increasing. Since I didn't get to the end result in writing, and didn't do it for a monotonically decreasing sequence. I think this is right, but okay. So, is there anything else? We did this prompt 3 involving chi. There was a little bit of discussion I didn't quite follow. Sarah mentioned that this is related to the squeeze theorem, and I didn't quite follow that. Basically what happens in this kind of sequence of intervals is that it constantly gets smaller and smaller, and it becomes just a little bit, or it gets like very close to 2. Just a little bit above 2 and just a little bit below 2, the bigger your ends get. And so the proof that was suggested in Zach's chat that made sense to me was showing that the beginning is always increasing closer to 2, and that the end is always decreasing and getting closer to 2. I don't know if it really counts as a proof, but basically like, the answer that I'm pretty sure you're supposed to get is that this intersection just results in whatever the end one is, because the end one is always the smallest one. So if you're going... Oh, I didn't catch this as out to infinity. I thought it was just an arbitrary endpoint, but not literally infinite. That makes a lot more sense for why squeeze theorem is involved. Okay. I guess I should have known that the ... was out to infinity. I for some reason I assume there's like a chi sub n somewhere at the end here, but there's not, so it goes out to infinity. This feels like a reverse of the squeeze theorem, where we know where it's going, but we need to prove either end of the inequality. Whereas with the squeeze theorem, you know either end, and you need to prove the middle. So maybe you don't necessarily use the squeeze theorem to do this. Hmm. See, I guess with infinite exponential, you do just get the number 2. I don't necessarily know how you prove that, though. That's what I've been kind of thinking about. This might be one where you need to listen to section 2's discussion or something to hear their ideas too. So we just move on, because we didn't look at 4 or 5. Consider sequence gamma sub n that is bounded. The sequence be convergent? No. It can be bounded but oscillating. Or there be a subsequence that is convergent. So I think all that's required to prove that the sequence isn't convergent is to use a counterexample. So we could name, say, -1 to the n as a sequence that is bounded between 1 and -1, but not convergent. But part B is going to be a bit of a task because I think a subsequence is convergent, but proving that means you actually need to prove something and not just write a counterexample. I do kind of need to use the bathroom here, so I think I'm going to put up my BRB screen and go and quickly do that. And maybe when I come back, I'll have an idea, but probably not. Let's see. So yeah, BRB. Okay, we're back. So, as promised, I don't have an idea now, because I was really thinking about it, to be honest. The subsequence that is convergent. I mean, So in the example that I gave with -1 to the n, yes, there's two subsequences, or I guess there's infinitely many subsequences, but there's two like basic subsequences where you take all the positive ones or you take all the negative ones. Those are constant sequences that converge. But how do you prove this in general? If it's bounded, must there be a subsequence that is convergent? The only way I can think to not have a convergent subsequence is if you have something that is truly random, which, when I say true randomness, I mean not just very erratic, but literally random. Because in computer science, that's kind of an issue where how do you actually get something that's truly random? Randomness doesn't actually like really exist in the universe. We just don't know how things behave, so we assign probabilities. As far as I know, at least. But then in math, you have stats and random variables. And you kind of hand wave where the randomness comes from. And I guess in quantum mechanics, maybe randomness does actually truly exist, but I'm not gonna, this is real analysis. I'll have to say, I don't think we would consider like a sequence of truly random numbers. And even then, maybe if it's truly random, I guess that wouldn't be convergent, but I don't think we're dealing with anything that's like that. As in like, I guess you can never find a convergent subsequence because you can never predict what the next value is. Actually, what a random sequence? No, you could bound a random sequence. I feel like I'm going in the wrong direction with, or going starting considering randomness. How do you go about proving that there's a subsequence? Throwing out that kind of random part. I feels like there must always be a convergent subsequence. Hey, Pernito, how's it going? Oh my god, number 5 deals with random numbers. Wait. I need to read number 5, because maybe I was actually on the right track. Wait. I honestly did not read 5 until just now. Really? So doesn't number 5 answer number 4? Or in theory, like, almost like you should do 5 before you do 4. Because this is a sequence of numbers that's bounded. It may not converge. So I'm glad I feel like I don't actually have, I feel like B is, there doesn't have to be if you allow random numbers. So I kind of want to look at 5 now, because this is exactly where my mind was going anyway. Assume that each of the numbers in the sequence is rounded off to the nearest hundredth. Will there always be... So basically, you're narrowing it down to a finite number of options for your random numbers. So that seems to be important. These are all rational, I think. Well, yeah, they will have to be rational for rounding to the nearest hundredth. And I would think that the answer is going to be the same as for the millionth. But we need to make that point, and we need to figure out why. So each of the numbers sequence are rounded off to the nearest hundredth. Will there always be a convergent subsequence in mu sub n? So, I feel like the points that A and B are making is that it should converge, but I feel like it doesn't. That's what I'm trying to figure out right now. Because how do you know what the nth number is? Like, you can't say anything about... Well, okay, if it's bounded... There surely are some numbers that are close. Is this for a given sequence of numbers, I guess? That you can then examine? But you still have the issue of, like, there's infinitely many. Hmm. And Pernito, if you have anything that you want to ask me or talk about, please feel free. Right now I'm just doing some study questions, but please feel free to ask a question if you had one. So, I think I need to start like typing up thoughts here so I can see how it looks in writing. And what better place to do that than in Zach's Discord? Wait, did I even write? Oh shoot, oops, impromptu. I need to edit my previous thing. Okay, there, I think that's fine. Or I need to, okay, there we go. A sequence being bounded isn't enough to show that it's convergent because of a sequence that oscillates, like -1 to the n. For B, I was thinking that, yes, there must be a convergent subsequence of sequence of random numbers. Coincidentally, which is also what 5 talks about. See how you can ever choose a subsequence that is always within epsilon of the limit, or of the bound, I guess. I'll say limit because bound isn't necessarily true. Can't predict what the next term will be. E.g., I think if you took every n squared term, how do you know what the n plus 1th squared term is? It's within epsilon. Maybe I'm misunderstanding, but this would make me think that you can never choose a convergent subsequence of a random sequence and verified it worked to, say, n equals 1,000. You know what the 1,000 first term is and whether it's within epsilon. to 4b and 5a through c is know that a convergent subsequence isn't guaranteed by being bounded. The wording of 5 makes me think I'm wrong, though. That's where I'm getting tripped up here, because 5 has parts like A, B, and C that seem like they're trying to like build you up towards saying that A and B involving rounding off are convergent and that C is divergent. I ask about rounding off, since it's asking about the effect of rounding off, it seems like it implies that rounding it would make a convergent subsequence happen, while not rounding wouldn't guarantee it. I guess this is all I have to say about this for 4 and 5. Okay. That's actually the end of the questions that were new for today, at least. Let me pull up maybe what were the questions from last time? Were there any interesting ones that I didn't get time for the last on Tuesday? Oh, there were some hard ones. I don't know if I'm gonna do these, but let's at least look. Let's zoom in. Make it easier to read. So we did that, I think, in class. Then I think I attempted this and maybe did it. I don't really remember, but I don't want to go back to it. This one I feel comfortable with. This one was brought over to the class today. Actually, both these were. Okay. Okay, now I heard Obi pronounce this as Kochi, I think, or something. I always just said Couchy. I don't know if one is right, but I'm kind of curious about this. I don't really know what you do with this though. So it's like the terms are getting very close together, it seems. And now that I'm thinking about it, I'm thinking about like a logarithm curve where it levels off and looks like it might approach one value, but it really just doesn't. Like it does, it goes off to infinity just very slowly. Same with like the square root of x. What is this song? Oh. It's like a pirate shanty. But, you know, would square root of n or log of n be considered Cauchy? So I guess we want to take... Maybe let's go to Wolfram. So if we took... maybe let's work with log, because that's what I thought of first. Log of 10,001 minus log of 10,000. Very small number. And everything after this, I assume is going to be even smaller still, which is the point. I'm not going to say it doesn't have to be smaller, we're just within the tolerance. So this was, let's take this exact same expression and just put some extra zeros in there. So that's 5 zeros and then a 9, and that's 4 zeros and then a 9. So, and if we did get another 0, yeah, okay, so the difference between successive terms is only decreasing. But this certainly doesn't converge, because log isn't bounded. So I think for part A, not all Cauchy sequences are convergent. The counterexample being a sub n equals log of n. Let's do the same experiment with square root. Just for funsies. So that's 0.004. And let's now do the same thing, the same exercise with putting more zeros in here. .001, which is less than .004. This levels off much slower, but it does level off. Now we get into the 3 0 territory. We had 2 zeros before. Still 3 zeros? Yeah, so the difference between the terms is going down. After a certain point, they're all within a tolerance. And then for 9b, are all convergent sequences Cauchy? I think that answer is yes, though. Because this one I probably need to go to the whiteboard for. This is way too big for me to get the entire question on one thing. I'm just gonna only show part B. Get rid of this too. Okay. I want to actually write out what I said for 4a as well. I should do that. There. I think that's all that needs to be said for 4a. Let me actually, no, that's not all. Well, that's all that needs to be said, but I want to say more. Okay. So yeah, the idea is that the they're like decelerating, you know. The second derivative, I guess, is 0 if I'm going to use calculus terms. But they still are, the first derivative is always positive. Is that actually true? Is that root n, if you derive root n, you get 1 over 2 root n, always positive. If you derive again, no, it's not 1/4. Is it? No, it's negative 3 over 2. Oops. That's always negative. Is it? You have a cubed. But it's always square rooted. Yes, that's always negative. Okay. So just short noise, things that I've learned in calculus. And then for log, I think the same thing. Always positive after n equals 1. Which is all that we care about in a sequence. Deriving a log, oh god. What happens when you derive a log? If you derive ln, it's 1 over that thing. If you derive a log, it's 1 over that thing times ln 10? Like ln of the base, I think? One over x ln of the base. Okay. So yeah, it will be 1 over n ln 10. So this is assumed base 10, but the base isn't really important for the argument. If you derive it again, so wait, sorry, this is always positive because n is always greater than 1. ln of 10 is positive because 10 is greater than e. Yes. Derive it again. Who was that? Temhem, thanks for the follow. Welcome in. I'm just doing some study questions right now, but If you have a question, feel free to ask it, please. Okay, so if you derive that again, you get just -1 over n squared ln 10. And that's always negative. Okay. That's kind of a neat little way to relate it back to calculus. Assuming that I'm right. I'm not full of crap. Let's actually write that down too. F prime x greater than 0. F double prime x less than 0. Okay. I feel like I feel pretty comfortable with A. For B, are all convergent sequences Cauchy? Which I think the answer to that is yes, and we do actually have to do a proof here. So, do we have the fact that a convergent sequence is bounded? I feel like it's something that we would need. Let's look around in our definitions and theorems and such. Oh yeah, I scaled this up. If a sequence is bounded, then it is convergent. Wait, this isn't the right problem set. This one had the typo in it. This is the right. I don't think the typo. Was that actually where the typo was? I don't remember. The typo's in one of these definitions here. Yeah, that was actually the exact definition that was incorrect. I'm glad I thought to check that because I was like, that doesn't look right. So if it's convergent, then it's bounded. That's what I wanted. So we need to make use of this leveling off that happens with the Cauchy sequence. Actually, I think, yeah, so we actually have Cauchy sequence as a definition in what we did today, because I was looking at what we did on Tuesday. Okay, so it's basically the same thing as what we have been given in the prompt here. So I think I want to make use of the boundedness and getting arbitrarily close to epsilon. Maybe we might not even need the fact that it's bounded, to be honest. For what I'm thinking immediately. I think that letter that Zach used for that is capital C, which is almost equally annoying to write. as lowercase c. I'm gonna say A. So consider a convergent sequence A sub n. Hey, Silvio. Es porque sí? Is why yes? I'm not really, my Spanish isn't very good. Hey, what are you trying to ask about something in particular? Um, and just let's start the definition of, being convergent. For all epsilon greater than 0, there exists and n belongs to n, such that for all small n greater than big N, you're from Argentina? Oh, hey, that's cool. Well, welcome in. Oh, and Zach over on YouTube. Hey. Silvio, but if I'm YouTube, well, hey, thanks, Zach. Silvio, oh my God. Okay, I'm gonna break out my horrible Spanish. ¿Tienes una pregunta? Or, how do you say hanging out? No? Okay. Well, welcome in. Anyway, hey. You're certainly welcome to hang out too. I just want to make sure that you weren't trying to ask me something. So, Zach, I've been working on the real analysis for a bit. I posted a few things that I worked on in your Discord, and I think I'm going to post about the Cauchy sequences from Tuesday, once I kind of work through it a bit more. You're all right? You want to see what you do? Oh, yeah. So, right now I'm just doing some study questions that are about real analysis. And what I do normally, if you caught me earlier in the stream, is I look around on the internet and I look for questions, math questions to answer, or if someone in chat has one, then that's always my preference to answer questions from people in chat. But yeah, it's kind of generally how it goes. And right now, I kind of ran through all the questions I was able to find out there online, so I'm doing some studying. So we're considering convergent sequence A sub n, and because it's convergent, we know that for all epsilon greater than 0, there's an n that belongs to natural numbers, such that for all small n past that big N mark, A sub n minus L, the absolute value of that, is less than epsilon. That's what it means to converge. And so I think what we need to do, because if it's for all n greater than that big N, that also means A sub n plus 1 minus L is less than that same epsilon. And I think that's some kind of fact that we need to use here. Larry Einstein, hey, it's going good for me. How about you? I'm just doing some studying right now. And I was happy to discuss and things like that. Welcome in. So I'm hoping here that we can find some way to combine this inequality with this inequality. If we just added them together and maybe did some triangle inequality stuff, what would happen there? You're good, bro. Working late? Oh, dang. Well, hopefully you get off soon. Thank you for hanging out with me. Analysis stuff here. Never did any analysis modules at uni, more physics and astro. Ooh, that's super cool. I guess that fits with your name too. So yeah, I always avoided analysis, but Zach, or e to the 2i pi on Twitch, has been teaching this live real analysis class on Twitch. And I've been participating in that and trying to learn it because I specifically avoided any type of proof-based class when I was doing my bachelor's in math. So actually, I should have just done exclamation point RA, but so yeah, the question I'm working on right now is just like a study question from that like live Twitch class. Normally I look around on like Reddit or Discord for math questions to answer that are like actually like homework help questions, but I wasn't able to find any more for the day, so I switch over to doing this like studying. Of course, someone pops in chat and has a question, I'll always stop what I'm doing. What's... Oh, hey, someone joined the Discord. Thanks to whoever you are. Okay, just make sure I didn't have something urgent to look at. Okay. So are all convergent sequences Cauchy? So if we use triangle inequality here, I need to look at the triangle inequality. Was it listed on this one? No. Where did, actually maybe it was listed in one of the problems. No. I need to open up one of the, whatever prompt. Yeah, sounds good, Larry. Sorry, I don't mean to like, you come into the chat and the first thing I do is advertise to you. It's just I think it's a really exciting thing that I've been enjoying. But you don't do anything that you don't want to do. Right now, okay, that I found the reverse triangle inequality. That's, I mean, no, it's not really what we want. Okay, let me just triangle inequality because I can never remember it. Okay, absolute value a plus b is less than absolute value a plus absolute value b. So by triangle inequality, oh, take down the cam. You forced real analysis down your throat, now you should be forced to, if you land at pi equals 3. Dude, if you're using pi equals 3, then I'm glad I did. It's better than pi equals 4, which apparently some people unironically do. Okay, now I forgot which direction the inequality goes for triangle inequality. The thing that I have is greater. Okay. Like that, I think, is our relationship here. Pi squared equals g is your favorite? Like the gravitational constant g? That's like a super small number? Oh no, like the acceleration due to gravity. Oh my god, wait, how close are those two? I never even made that connection. 9.81? Yeah, I'm interested now. I never thought about pi squared. 9.86 versus 9.81? That is way closer than I thought. Wow. That's a really funny approximation for it. You know, that's why everyone should be using feet per second squared. I'd rather it be like 32 point whatever it is, I think, or it's 30 something. So wait, am I nearly at the end here? Or I might want to do a different choice of epsilon, but like, we have a sub n plus 1. Oh wait, we need the difference of these two. Can I be sneaky and factor out a -1? Because it's an absolute value. It feels like cheating. But this is also true. And that would give me... Wouldn't that give me exactly what I want? Which is that a sub n... Oops. Minus a sub n plus 1 is less than, well, 2 epsilon, but that's still the scalar times epsilon. But so for part B, we're given it's convergent though, isn't it? Okay. We're talking about the difference of two terms. So, I mean, I guess we could make it come out a bit cleaner and make our initial choice epsilon over 2. Okay. That wasn't as bad as I thought it'd be. It almost feels like cheating, but maybe that's all there is to it. I'll take a screenshot of this and put it in the Discord for the for Tuesday's session, because that's where this question came from. And how am I gonna... Let me take down the Firefox, so that way I can open up my stream again. Let me go and find my stream. Okay. I actually, without someone else like jumping in to help me, I actually got to the end there on my own, I think. I mean, maybe I did something wrong still, but should have for consecutive terms. Oh, hey Scorpra. They're not necessarily consecutive for a Cauchy sequence. That's for any arbitrary combination. Huh. Because I feel like... Yeah, I guess not. Because we're already given that both A and B are past n. So actually, yeah, you're right. Because by the definition of Cauchy, A and B are past n. Okay, yeah, so Well, okay, now I'm getting like... Okay, so let me... This line is okay. Let me change this line, though. I'll keep the epsilon over 2 thing, though. Epsilon over 2. Take a comma b greater than n. Then a sub a minus l. Well, that's kind of bad if I'm going to use a and a. A sub a. I'll do c and b, I guess. Or b and c. And a sub c minus l. That's an epsilon over 2. Okay. And now the same exact logic applies. I just need to change the names of things here. Okay. Cool. Wait, you disagree with my counterexample part A? Both of them? Graph log n minus square root n. Oh yeah, Einstein, sure. So I kind of cut that part off of the problem because there's like a page break and it was a little bit awkward to get everything on one screen. But the Cauchy sequence is defined right here, where basically after a certain arbitrary point, any pair of terms that you can name are less than some tolerance. And that like certain point, as I said it, is capital N. And so for any A and B past that capital N, the two terms of that sequence are very close together, basically, for whatever error tolerance you want. See, I had heard that the term Cauchy sequence, or Cauchy, I know I'm pronouncing it wrong, but I never had to work with them until now. 20 watch streak, Scorpra? Oh my god. Thank you. Cauchy? Oh, I thought that was something else. People were saying Cauchy? I thought Cauchy was a completely different type of sequence. Like, oh, so we have a Cauchy sequence and a Cauchy sequence. Okay. That makes so much more sense. Like, oh, I thought like, I was imagining Cauchy, I thought like K-O-S-H-I is what people were saying. Okay. I think I never really heard people pronounce it Cauchy. Okay. So I don't imagine this converges. Euler being pronounced Euler, yeah, instead of Euler. So wait. So the question was, are all Cauchy, I'll say Cauchy again, are all Cauchy sequences convergent? And I said no because log of n and square root of n, they level off, but they don't approach a particular value. In this one, infinity minus infinity, which is indeterminate. Wait, so it doesn't converge. But it probably, I would bet that it's Cauchy. Because we, for the sake of A, if I'm saying it's going, there are divergent Cauchy sequences. It disagrees? Oh. Wait. What am I missing? Are we about my calculus bit? Because I guess this is a negative first derivative. But that was like a little like side expansion. It's not supposed to be all that rigorous, I guess. Or I guess you can make the same argument, but with like the reverse signs. Where f prime x is always less than 0, but f double prime is always greater than 0. It's always negative past a certain point. Yes. So I think, I mean, so I guess I missed a part in my little thing here with my little like in calculus terms aside, but you could, I guess you could also have f prime x less than 0 and f double prime greater than 0. Just flip each of the inequalities, because I think f double prime is greater than 0. Sequence is always decreasing. I guess I should look at the second derivative too here. So second derivative was positive after a certain point. Root x plus 1 minus root x isn't Cauchy. So, okay, I guess maybe I should back up. The way I was checking for something to be Cauchy is I was just plugging in very big consecutive numbers. I guess you don't have, they don't have to be consecutive, but oh, maybe doing consecutive was a mistake. Maybe because so if I say my wait, how that's 10,000? That's 10,000 again. So if I just do like oh yeah. I should be able to add on any number of zeros to this, and it'll always be within some bound. So did the sequence that I named aren't Cauchy. So Okay, I guess that's the issue. It does seem like it's... I'm adding on... Maybe there is some error response or something, but I don't think so. No, there shouldn't be. So I was only thinking in terms of consecutive terms, which is why things looked Cauchy to me, but it's anything after a certain point, I guess. So it seems like, what's the difference between a Cauchy sequence and a convergence sequence then? Or maybe there is none, and that's the point of that question. So I could kind of reverse the proof that I just did for part B and maybe show that a Cauchy sequence is also convergent. All right. Oops. Okay. That can go away. So maybe Cauchy really just wanted something to be named after him. Like, is that the point here? Because it seems like it would just be, you should just call it like, a property of a convergent series. Sequence. Okay. So now we need to start with the Cauchy sequence and want to show that it's convergent. A sub n. I can't believe I just wrote A sub n there. Okay. Consider a Cauchy sequence A sub n. That means wait, root n plus 1 minus root n is Cauchy. Oh, okay. Hold it. Okay. Hold. Someone the one is messing up Cauchy sequences. Shitty. Then I was meant to be an absolute value bar, but it also works as a capital T. Then there exists an n belongs to natural numbers such that it is Cauchy? Okay. AB greater than n. No, not AB. I'll do BC again. I don't really like doing BC. I feel like there's something better I could use, but I'm too lazy to think of it. AB minus AC is less than epsilon. Okay, and now I think we do the same exact thing, but in reverse. Got to do a plus L minus L thing. and then pair them off. AB minus L, so they have opposite signs, minus A sub C plus L, that's an epsilon. And then by triangle inequality, this. Ooh, but then we lose resolution on the epsilon, don't we? Like, we don't know where the epsilon fits in here. Our triangle inequality is going the wrong way, I think. So maybe we can't do the same exact thing. Well, I mean, it shouldn't be, though. Wait, am I just misreading this? No, it's fine. This is less than that, which means this is still less than epsilon. Yeah, no, there's no reason it shouldn't work in reverse. I was just misreading my inequality signs. I think. Let me just stare at it for a little bit longer. No. This does not work in reverse. Okay. At least not the way that I wrote it. Because I did have the signs right the first time. This is greater than that, but we don't know if how this compares to epsilon is the issue. As far as I can tell. Now, what if, like, there's the reverse triangle inequality that we could get in here. Sorry, I know the browser is messed up, but... Oh wait, let me just check against the actual triangle inequality first. Just make sure I have the signs right. Is right. The thing that I have is greater than that. Okay, so that's the forward triangle inequality doesn't seem to help me here. The reverse maybe does. So let me copy down the reverse triangle inequality. Absolute value x minus absolute value y. It's less than or equal to x minus y. So can we maybe engineer a situation like this? Actually, I didn't pay attention to the sign, whether that sign would possibly help us. So I guess let's do the obvious thing and try applying the triangle inequality straight up to this without doing the plus L minus L thing yet. Hey, Anders. I'm working on some problems from Tuesday on the Cauchy sequence. I believe I have it right for part B, but Zach pointed out that I did part A horribly wrong, so I'm trying completely different approach here. So this is greater than this. It's still less than epsilon, which is the issue that we were having before. And so I want to show that A sub n is convergent. That's the goal. I don't know how this is going to help us yet. First triangle is when you have stuff in a denominator that you want to bound. I don't have that situation. I was kind of trying anyway to see what happens. I think here I do need to do the plus L minus L thing first before I apply the reverse triangle inequality. And I don't know how these are going to show that we're converging. I'm just not going to think about that part yet, I guess. So let's do an A sub B minus L minus A sub B C plus L plus an epsilon. Now let's do reverse triangle inequality. Let's actually make it a bit more clear what's happening. Now what? Go bounding the other direction? I don't think so. I mean, I don't know if this is helpful, but I think what I have is valid at least. Still trying to figure out if it's helpful. But I don't think I've done anything that's invalid yet. Everything on the same line, you see what I mean? No, I mean, this still works. Oops. As far as I know. The signs are going the right way. It is valid, but it goes in the other direction. Well, I mean, we don't want something that's greater than this, because then if something that's greater than this, we don't know how to compare it to epsilon. It's like, I think that's what the purpose you're trying to prove. Well, something like from this part, we could somehow break it up into two separate things. We don't necessarily know. Are you sure? Because I feel like that there is something here that we can do. Like, I want to show that A sub B minus L is less than epsilon, and A sub C minus L is less than epsilon individually. But maybe we can't make a statement like that because we just don't know how these two compare. Well, what I was hoping is that we could do like minus epsilon is less than A sub B minus L minus A sub C minus L is less than epsilon. And then from here, do something that's vaguely helpful, but Like use like the sum of two sequences property theorem thing that we proved the other day. But you're right, maybe this isn't helpful at all. This was kind of like what I was investigating, I guess. Which I can't think of how we can possibly break these two up. Or like, I'd love to make some kind of like, we don't know anything about a sub b minus l on its own is the issue. It's like, you know, one of those terms could be huge, the other term could be small. You replied on Discord? Oh, I didn't see that. It is not required to choose the index in a regular pattern. But then how do you choose an infinite? I saw our reply in Discord too, in case someone else wants to join the conversation. But if you don't choose it in a regular pattern, like how do you ensure that it's an infinite subsequence? How do you make the choices for what indices you take infinitely many times? Hey, Zone Ranger, Bolzano wire stress? No, or at least not by name. It's like, I assume that you're not allowed to just like, you know, make your you're not allowed to choose a subsequence based off the results. That was my assumption. Every bounded subsequence of real numbers has a convergent subsequence? Oh, okay. So I was thinking that the thing with the random sequences, I couldn't find a way to make a convergent subsequence out of a random sequence, I guess. If you min or max the choice, you pick the index. Yeah, Zone Ranger, I agree. I don't want to touch things that we haven't learned yet. I guess that question probably is just Bolzano wire stress. The one that was, or it's literally exactly that. I was working this one earlier, and then I switched over to Koshi. So I guess we're nearly there, but maybe a next meeting. It'll show up on our theorem list. Min or max assures you can pick the index. Hey, Hoo, welcome back. Okay, so do you have to do it for, like, if you take the min or max, do you have to do it for a fixed number of indices? Wrong answer, it's Spectry. like, you know, I guess you can make like an algorithm that's basically like, you know, for every, you know, 5 indices, take the min or the max of them. But you're not assured that those 5 indices are within that tolerance, right? And if you're talking about mins and maxes, why not just say go along the sequence until you find one that's within the... Yes, I guess you can make a better algorithm than the one that I said, but I guess if you're allowed to look at what the number is, that was really my issue, that I thought you weren't allowed to look at what the number is. You have to do it solely off the indices. And maybe the... And in a sequence that isn't random, you can use the pattern to help you out too. But with a random sequence, you have no assurance of what the next number is. So I guess you could say just go along the sequence until you get things that are what you want, and then you're good. But I don't know. Yeah, I was going through my head like, oh, what if you have the sequence that's just like 1 1, like, you know, even though it's random, what if you happen to get 1 1 1 1 1 1 1, but then it's just a constant sequence, so that does that, you know, clearly converges. If we chop the interval in the middle, what would we get? Oh, if it's bounded, we chop the interval in the middle. I don't know, it's random. Like, you just literally cut the sequence in half. I don't know how we say anything about it, I guess. At least one of the sub-intervals that has infinitely many terms. Right? Oh, that's what you mean. I thought you were trying to make seem about the actual thing, the things inside that, yeah? Right, so you're allowed to chop off parts that you don't want, that are finite. Because you only care about, I guess, the end behavior. But when it's random, you don't necessarily want the entire interval, you want a part of it. Oh, like keep chopping it? Oh, okay. Well, no worries. Once you're back, I'd like to keep talking about it if you want to, but go do your stuff. Okay, in the meantime, let me think more about this Koshi stuff. Felix, I've been kind of bouncing back and forth. So what I was really just talking about now was, oh, we haven't learned that. Zone Ranger was just suggesting that. That's not something that we've learned. But we were talking about 5 and technically 4B too, but I've been kind of flipping back and forth between this whole thing with sequences of random numbers bounded sequences of random numbers, and number 9 regarding Cauchy sequences. we can't use things we haven't learned, so I'm sure it does help, but it's not something that we've learned. Hmm. I know, I'm just gonna. I'm gonna put a pin in number 5. I'm more on the track of number 9 right now. So I've done part B. I thought I could just reverse my logic to prove part A, but it doesn't actually work out. So I kind of back to the drawing board is trying to come up with a new strategy here. Hmm. Okay. Let's erase this because I don't think it helps. Okay, so ah. So it's Cauchy. We're not assured, you know, we want to prove that after this big N point, we're approaching some kind of limit. But we can't use... Oh my God. So... can I use the triangle inequality in a different way? So it feels like I need to do some kind of trick like this, even if it's not exactly that. If I instead started with a plus b minus, or a sub c minus, it doesn't matter. Whatever the heck I'm trying to say. And a separate thing plus L minus L, let's say. That's still less than epsilon because L minus L is 0. I still don't know if this is the right track, but now we can use the same triangle inequality I had here. Am I just going to prove the same? I don't know. No, I just got the same exact thing that no, that's no good. Because this is where I started to use the reverse triangle inequality, and I found that that wasn't helpful. How do you do this, man? Hmm. We're not given any other facts, right? Right. But you want to prove that a sub n is an epsilon? Well, yeah. I've gotten that far at least. But how we do that is the tricky part. Because, like, I can see intuitively how this works, where if the terms are, like, very close together, then... it should be converging on something. Do you know anything about boundedness? All we know is that it's Cauchy, and being Cauchy doesn't imply anything else besides this absolute value business here. So we know the difference of two terms is bounded. We don't know the sequence overall is necessarily bounded yet. I don't think. But maybe if we could show it's bounded, that would be helpful for convergence. Okay. How can we show it's bounded? Well, maybe this is cheating, but if we know that minus epsilon is less than a sub b, minus a sub c is less than epsilon, and we added a sub c to everything, could we say that c is an arbitrary point in the sequence plus a little bit of tolerance, and that b is also an arbitrary point in the sequence, and that a sub b is less than... Well, that's not... That sign isn't quite right, is it? If we subtracted over, we'd have the same issue. Can we have to revisit that problem set 5? Oh. Who is that? Hypatia Dubois Marie? Wow, that's a good name. Thank you for the follow. Problem set 5. Like, is that a problem set that we've already done, or one that's coming? Like from day 5? Oh wait, this is problem set 5. Because I was going back to Tuesdays. This is all like the stuff we're doing on Tuesday. Oh, the triangle inequality is written here. I just completely missed it. I think I might have skipped over some of these problem set 5 ones, to be fair. Hmm. Being Cauchy doesn't necessarily imply monotonicity. Oh. Ha, that's funny. Oh, someone else also streaming analysis? Or if you're talking about Zach's or E2 Pi's analysis streams, then yeah, I've been participating in those and I'm working on some of the problems. The stream is mostly about like answering homework questions, but if I run out of them, then I switch over to this analysis stuff. Just for some like studying. Either way, welcome in. Thanks for being here. Do an algebra / category theory stream. I know there's people who will be interested in that. It's nothing that I don't know the first thing about either of those, but there's only people who ask about it. I've been kind of scrolling around, so right now I'm currently stumped on 9A. And I'm kind of to the point where I just need to, I think, drop it for now. Just try to come back with a fresh mind or after we've had a few more classes and learned some more stuff. You know, at least for now, I am gonna screenshot what I did for 9B and post that in Zach's Discord. Let me, I'm sorry, I'm gonna take away the Firefox screen for a second so I can screenshot this. Because I need to take a screenshot of my actual screen. That's the easiest way for me to do it, at least. Okay, there's that. Bring the Firefox back up now. So I'm getting to the point where I might just switch away from doing math, do some Baba is you or something. Um, I'm just posting right now what I did. Okay, cool. So I won't fully switch away from math yet. Let me take a quick look at maybe I have some DMs or something on Reddit from someone that I was helping out earlier. I actually do. Okay, so before I switch away from math, let's see who replied to me from the actual homework help part of the stream. Sorry, Paige, if you're still looking at this problem. If you want to see it again, let me know. Or if you want to discuss it, but there's people that I replied to earlier on in the day. It isn't going to be much for me to reply to, apparently. See, I helped this person out with their kind of proof for a log identity. And they said thanks. And then my other DM, just another thanks. Okay, never mind. There wasn't much for me to get back to. Let's just do a quick extra look at homework help. See if anything new just got posted. Ooh. Differential equation. I can probably actually do it because they're in Calculus BC. So condition y of 0 equals -1. Find the particular solution of the equation xy dx is equal to e to the negative x squared y squared minus 1 dy equals 0. There's no way in hell this is an exact equation. Is it separable? Yes. What do? They separate it. Good. Subtract the xy dx over to the other side, so the negative sign comes up there. Oh, okay, no, you can do that in integration. They do u equals x squared. That should be e to the negative u. Thinking about monotonicity plus bounded implies convergence requires axiom of choice or some weaker form. Oh, you know that requires the axiom of choice. We haven't gotten into that. I know it has some very weird results from it though. That is interesting though. Oh wait, no. They're okay because they say e to negative x squared. But you can bring the e to negative x squared up and make it e to the positive x squared. So their stuff is okay. There's still a negative sign out in front. The x goes away. I don't know exactly how they have written things, but this is valid. So why do they think this is wrong? Somebody needs to help me with this differential equation. And the result for y looks perfect. So what's the issue? Let me give Wolfram alpha the differential equation and see what it says. xy dx. I don't know if Wolfram alpha is going to interpret this right. Let's just see if it does. It'd be kind of fun to see if it knows what I'm trying to say. E to the minus x squared y squared minus 1. Wolfram alpha writes it in a weird way, but I think that's the same thing. Yeah, it is. Okay. Oh, that's not the solution you want to see. Oh, because they sold it explicitly for y. Okay, well, they're not going to give me in a more helpful form. I'm confused with this. Let me go through and solve it for myself, I guess, and see if I agree with what they have so far, because I'm kind of confused on where they're stuck. Their work looks good. But it's a mistake that I am not going to notice until I try it for myself. Oh my god, please erase. Okay. So initial problem, xy dx plus e to the negative x squared, y squared plus 1. I think it's minus 1. It is minus 1. Sub y of 0 equals negative 1. Oh, not 11. Okay, negative 1. xy dx e to the negative x squared, y squared minus 1. Okay. So let's follow along their exact steps. Subtract over the xy dx. So divide over the e to the negative x squared and divide the y over. Dy is equal to minus x. I said x and I wrote e. Minus x e to the positive x squared, because e to the negative x squared is in the denominator, so we may as well just bring it up top. Now we integrate each side. Y squared minus 1 over y is the same thing as y minus 1 over y, which is much easier to integrate. That we're going to need to do a little u sub for. I keep putting the negative there. U equals x squared, du equals 2x dx. Okay, so that integrates directly to 1/2 y squared minus ln y is equal to minus 1/2 e to the x squared plus c. Because we just turned out to integrate e to the u, which is just e to the u. Plug in our initial condition. Actually, well, does this agree with what they got? Yes. Plug in the initial condition. Ever see why we put -1? Oh, do they not do the absolute value? No, they do the absolute value. So yeah, plug -1 in for y, 0 in for x. 1/2 times 1 minus ln absolute value of -1, importantly. So minus 1/2 e to the 0 plus c. 1/2 minus ln of positive 1 is 0. E to the 0 is 1 times -1/2 is -1/2 plus c. Oh, that's annoying. They didn't engineer it so that c equals 0. C equals a quarter. No, c equals 1. It's 1/2 plus a half. I assume 1/2 times a half for some reason. Okay. So the answer is 1/2 y squared minus ln y is equal to minus 1/2 e to the x squared plus 1. And there's nothing wrong with that. We haven't solved for y explicitly, but that comes up pretty frequently with separation of variables. Um, it's okay that we can't solve for y explicitly here. Currently in. That was the question. Okay. Let's see. What's up with this? Oh, okay, they already have an answer though. I think the person already put like thank you and a heart in their title, which is kind of nice. There's not much new on this subreddit. Okay, I think at this point I'm all mathed out. Let me see if there's anyone streaming math that I can recommend you to. I don't see anyone doing math right now, unfortunately. I'm gonna do so I'm switching over to Baba as you, and that's gonna involve cutting off the YouTube stream. But I do want to do a general plug for Zach, aka E to the 2 Pi's real analysis stream. The next one's gonna be happening in an hour and 15 minutes or so, I think. So I highly encourage you to take a break and then head over and check out Zach's real analysis course. For now, there's no one that I'm aware of who's streaming math, unfortunately, but there's at least that happening in an hour if you're interested. I'm going to cut off the YouTube stream and say goodbye to everyone on YouTube. Thanks so much for anyone on YouTube who's been hanging out. I appreciate you. I'm planning for the foreseeable future, I'm planning to keep on dual streaming, so, and hopefully the YouTube stream will only get better and better as I figure out how to work it more. Yeah, if you're on YouTube, I appreciate you. I'm going to keep things going over on Twitch, though, with Baba Is You, a really fun puzzle game. And, actually, let me... Twitch. Yes, see you, Larry. Oh, come on. The Nightbot is really slow on Twitch. Okay, there. So yeah, now I'm going to cut off the YouTube stream, so if you're on YouTube, I'll see you around.